Hi guys, welcome to the CAD review. I'm gonna walk you guys through our V1 design. So this is going to be a fixed shape bar, and I'll show you how it works. This is the drive base. It uses WCP Swerve X, the flipped variant, which means that the motors are on the bottom facing up. The key thing about a swerve is that instead of just spinning the wheels so you can go forward and back, it also simultaneously turns them. This means that you have the full power of all four motors in any direction. This is better than, say, an X-Drive, because in an X-Drive, when you're traveling diagonally, you only have two motors pushing. And when you're moving forward with an X-Drive, the motors aren't in line, they aren't parallel with the line of travel, so you're not getting max efficiency. So the way we mount the swerve modules are just with these four pieces of stock. There is a 1032 bolt that goes through, and these holes on the swerve are tapped. So that's how that works. Next, we have this inner frame, and these are gusseted on, right? So these L gussets, I think we got them from ThriftyBot. And yeah, next we have the E-board. The bottom of this frame will have M6 riv nuts. If you guys don't know what a riv nut is, it is just a threaded insert for metal basically, so you can screw into it. So this is going to be the battery plate. It's dropped down a little bit because the battery is quite thick. It's 3 inches thick. So if we measure from here to here, you'll notice that this is exactly 3 inches, which means that the battery will sit flush with the top of the drive base. The rest of the E-board is dropped down by ½ inch such that wires can travel through. So for example, we're going to have a wire path from this part to go right into the battery area. And here we have assorted E-board stuff, RoboRio, our POV injector, and then over here we have just some small Darwin plates that are going to allow EMP to, do some neat wire management around each of the swerve modules. So the key thing about the modularity of this drive base is that here you have two rivet nuts, M6 as well, and at the front here we have options for a hypotenuse support. So now we move on to the second part of our robot, which is the pivot plus the triangle support. As you can see here, this is going to screw into the riv nut. You're gonna have two anti-mark sport gearboxes. I believe these are like 100-1 or something. I can't tell you off the top of my head. Powered by two Falcons. Then it's gonna turn this sprocket, and it's gonna connect to this sprocket via chain, right? So path of chain looks something like that. And the way we're gonna do a chain tensioner is with something called an inline chain tensioner. Since the distance from here to here is greater than the distance of half the circumference, this chain tensioner will never reach either sprocket, which means that it's okay to have an inline chain tensioner because it's never going to bend. This is favorable to a cam, because a cam you're going to have to mess with cutting slits in the stock. Okay, so the result of this pivot is that the sprocket moves. Next we have the chain bar. So as you can see, this is the sprocket from before. When this thing moves, the entire thing is going to pivot up and down. We're going to be using something called a chain bar or a virtual 4-bar. And why this is important is because we want our end effector or manipulator on the end to always be parallel to the vertical structure or perpendicular to the ground. Here's a pretty cool demonstration of how a chain bar works. You'll notice that a single sprocket is static, and it means that the end effector is always going to be parallel to the ground. This is our end effector. I'm not sure if you've seen it before. I'll pull up the video. Yeah, so this needs to stay parallel to the ground because otherwise it won't pick up effectively. Now, if we combine them together, let's see if I have a master file. We get our basic version of the robot, which is the non-elevator chain bar. And what this robot can do is pretty much everything we needed to do, which is level 2 cone. It does not do the high cone, unfortunately. It does level 2 and lower. And it's a very simple design, and we are pretty sure we can pull this off. Just in case I didn't make this clear, this attaches to this. So this will stay parallel, and this is the one driven by the gear. Okay.